Section 4 of Chapter 3 is more word problems. You know you love them. Here we go. All right. The book titles this section Rates. I would tend to call this travel problems. And no, I don't mean the airline lost your luggage. I mean, are we traveling in the same direction or opposite directions? And how far are we going and how long is it taking us? We're going to simply use the equation D equals RT, where the distance equals the rate times the time. So distance equals rate times time. And normally that time is measured in hours. Sometimes it's not, so you'll need to be sure to read carefully and watch your problem. You know what? I only have 2 problems for you. All right, here we go. So the first type of problem is when 2 items are flying in opposite directions. All right, if they're going in opposite directions, then what we're going to end up doing is we're going to end up needing to add those distances together to find what those distances are. Because we've got 2 fighter jets, they're flying toward each other. The eastbound jet flies at 582 miles per hour, and the westbound jet travels at 625 miles per hour. If they're 22 miles apart, now that's when they start, they're 22 miles apart, how much time will it take for them to meet? So your first step is going to be to draw a little picture. It doesn't have to be lovely. So we've got one airplane traveling this way and one airplane traveling this way, and we know that the distance apart is 22 miles. We don't know how far each of these planes is traveling, but we do know that this one is traveling at 582 miles per hour, and this one is traveling at 625 miles per hour. Now they're going to travel the same amount of time, right? So their distances are going to be different. The time is going to be the same, but their distance is going to be different because this one is traveling faster. He's going to go more than halfway. So we can't set them equal to each other, but we do know that they're going to meet, so they're going to use up all this space. So the distance of one plus the distance of the other is going to equal the 22 miles altogether. So back to our distance equals our rate times time. So the distance is 22 miles. That's how far they go. The distance equals this rate times time plus this rate times time. And the time is the same, so we can just call it T. So this one is 582 times your time, and this one is 625 times your time. So if I add the distance this plane goes and the distance this plane goes, the total distance together should be 22 miles. So once again, it's a simple matter of just solving it. So we've got 22 equals 582 plus 625, 5, 6, 7, 8, 9, 10, 11, 12, 1,207 T. And then, now be careful because this looks all crazy because you got the huge number on bottom, and that's okay. Watch this. Because the 1,207 is what is multiplied by the T, that's what we have to divide to get back to the T by itself. So when we divide that, put it in your calculator. 22 divided by 1,207 is 0.018. That 0.018, remember, this is miles per hour. So be very careful with your time. 0.018 hours. Now, is this a reasonable, it is a reasonable amount of time, but is it a reasonable answer to give? If you have 0.018, you probably want to give that to me in minutes. And the way you can do that is simply say, well, there's 60 minutes in 1 hour. So if you take that 0.018 of an hour and multiply it by 60, 6 times 8 is 48, 1, 6, 7, 8, 9, 10, and move your decimal 1, 2, 3. That's a little bit more reasonable. So the amount of time it's going to take for those 2 planes to meet is 1.08 minutes. And did I go back and forth between T and X? I did. These are, oh, this is a times and this is a T. Haha. There we go. So our time that it's going to take for the two planes to meet is 1 minute or 1.08 minutes. All right. All right. Then let's see, what's the next kind? Oh, okay. So either we can have people traveling toward each other or away from each other. We can also have problems where the travel is happening in the same direction. All right. So in this case, we've got two people bicycling. Jim and Angela are biking at on the same trail. And along the way, Jim passes a certain marker at 9 o'clock a.m. Angela passes that same marker 5 minutes later at 9:05 a.m. Jim is riding at 8 miles an hour and Angela's riding at 10 miles an hour. What time will Angela catch up with Jim? All right, so once again, we've got distance equals rate times time. And in this case, so we've got distance equals rate times time. So we've got Jim and we've got Angela. Let's set up a chart because you know charts are fun. Charts and pictures. So we can set up a picture. We also have a picture where Jim and Angela are going the same direction. So their distance, this distance and this distance, we want to be the same. We want them to end up at the same place at the same time. We know Jim is riding at 8 miles an hour and Angela is riding at 10 miles an hour. So now we need a distance equals rate times time. So rate is 8 and 10. So we've got the rate. We need the time. The time that they're going to travel is going to be determined by, oh, check it out. So Jim passes the marker at 9 and Angela passes the same marker at 9:05. So the time starts when Angela passes that marker. Jim's got a head start, but Angela's starting right at the 9:05 mark. So Angela gets X amount of time. But remember, Jim got a head start. So he has X amount of time, but he's going to add that extra 5 minutes to his time. So if he's got X plus a certain amount of time, how are we going to show it's 5 minutes, right? X plus 5 minutes. Well, the trick is the time throughout the problem has got to be in the same values. So if we've got miles per hour and we've got minutes here, we've got to get them into the same set of time. So we've got hours and minutes. We want to change these minutes to hours. How much of an hour is 5 minutes? Well, we know that 60 minutes is 1 hour. So 5 minutes is 5/60ths of 1 hour. So that 60 transition number is going to be used a lot. We used it in the last problem. We'll use it in this one. And then if you've got 5/60ths, you can reduce this down as 1/12. Okay, so now Jim is traveling at 8 miles per hour for X plus 1/12 amount of time. And let's just make that neater, X plus 1/12 now, because that's 1/12 of an hour. And Angela is traveling 10 miles per hour for X number of hours. Now, the distance, we don't know what the distance is, but check out our picture. The distance is the same. So if the distance is the same, then Angela's distance is 10x. Jim's distance is 8 times x plus 1/12. But those distances will be equal. They're the same. So now we have an equation that we can solve. So if you're going the same direction, then your distance is going to be equal. So you're going to have an equation where your two distances are equal. Whereas in the other problem, when you're going the opposite direction, you're going to add those distances together to get a total distance. So now we simply solve it. Once again, here we go. We can do this. So 10x on this side equals 8x plus 8 times 1/12 is 8/12. And we can reduce this down, divide by 4. This is 2 times 4, and this is 3 times 4, so the 4's reduce, and I have 2/3. So, let's see, so 10x equals 8x plus 2/3. So subtract 8x from both sides. So 2x equals 2/3, and remember we're talking about hours now in time. So when we divide by 2, that's the same as multiplying by 1/2, which turns out really neat and easy here. So x equals 1/3. Now, here's the deal. X equals 1/3 of an hour. So once again, if we've got a portion of an hour, let's change that to minutes. And we've already talked about, in order to change minutes to hours, we're just going to, or hours to minutes, oh dear. In order to change these hours to minutes, we've got to multiply by 60. And when you've got this fraction, let's put 60 over 1. And the 3 and the 60 will, 60 is the same as 3 times 20. So we can reduce by the 3. And so x equals 20 minutes. So how long? Let's see. So let's go back. So x is 20. So Angela is 20 minutes. All right. So now, remember, we've got to go back and answer the question that was asked. The question that was asked is, what time will Angela catch up? Well, what time did Angela pass that marker? Angela passed the marker at 9:05. And then she traveled for 20 more minutes. So you're going to take the 9:05 plus the 20 minutes. So she's going to catch up at 9:25 a.m. All right? So that's all you're going to do today is those 2 types of problems. You can do this. All right? I will talk at you later.